Hello everyone, welcome to Dr. Ravi's Academy. In today's video lecture, we will be understanding the basic concepts of engineering mechanics. So in this, we will be focusing on, let us see that the concepts today's class covered, or we are going to define what is meant by rigid body, then particle and system of particles, force, and finally mass of the body. So these are the topics we are going to discuss in detail in today's class. Let us look at the first topic, that is rigid body. If you consider a body and it is subjected to system of forces, number of forces with different magnitudes and direction, if the body is able to retain its shape and size after the application of the forces is called rigid body. That means the when body is subjected to forces, obviously certain degree of deformation takes place, deflections and deformations. That means there is a change in dimensions of the body, change in shape and size of the body. So, if the body is able to retain its shape and size, so that body is called rigid body. And this is what exactly the idealization or assumption in engineering mechanics. So, that is the reason engineering mechanics is also known as rigid body mechanics. For this, let us consider an example: a bar supported exactly in the middle and subjected to loads at equal distance, and the bar is it is supposed to be straight after application of the loads also. So this you can call it as a rigid body. And whereas the other side, let us consider the body is deformed after application of the loads. Let us say like this: there is a deflection or deformation in the body after the application of the loads, then this particular body is a deformable body. Deformable body. So this is what exactly the difference between rigid and deformable body. And whatever you consider the rigid body, because it is subjected to loads and the material usually it is elastic in nature, you have a certain degree of deformations. Never you have a 100% perfect rigid body. If the deformations, the definition is like that, if the deformations or change in dimensions are very, very small when compared with the overall dimensions of the body, then you can treat that body as a rigid body. And this is the definition of the first concept. And second one is it is particle and system of particles. Let us consider a body, and if the dimensions of the body, if the physical dimensions of the body is no role to play in the analysis of the kinematics and kinetics, let us say, then the body may be treated as a particle. If you look at that cricket ball, it is thrown toward the wickets, and this particular ball is, you can call it as a projectile. So we are analyzing the motion of the particle, that is cricket ball, and we are focusing only the center of gravity of the ball. We are not considering the dimensions, and that you can treat that it is a particle. And the other definition is system of particles. Number of particles more than two are connected in such a way that the motion of the one particle depends on the other. Let us consider for this a simple diagram. You have three bodies, three blocks. One is A block is on the horizontal plane, and 2 is, that is B is on the inclined plane. Again, C is on elevated horizontal plane. Let us consider this is example, and these three are connected. You have, by means of a flexible member, these are connected, and you are applying some force, external force P, and let us say you can call this particular system is system of particles. You have more than two, A, B, C, three blocks, and the motion of one particle depends on the motion of the other particle, and you can treat that it is it constitutes a system of particles. Third definition, that is force. The action of one body upon the other is called force, and that force may be pull or push. And in order to define completely the force, you need to specify the various parameters, and these parameters are known as, characteristics of the force. You can call it as characteristics. You can call even specifications, and even you can call it as parameters. All these are the names. So you have to specify completely. Means first one is the magnitude of the force, magnitude, direction, and third one is point of application, of that particular force. For this, let us consider a block resting on the horizontal plane having a mass of m. So to discuss these three parameters, let us consider C is the center of gravity of the body. The magnitude of the force, weight is acting vertically downwards, that is the W is equals to mg. The direction is downwards. The point of application is the center of gravity of the body. So all these three parameters are essential to define completely a force. And the last definition is, that is the fourth one, is mass. Mass is the fixed quantity of the matter possessed by the physical bodies, and it is an invariant property, and this you can call it as resistant for the linear motion. Now if you look at this Newton's second law of motion, sigma fx is equals to mass into acceleration, where this m is the mass of the body when a body is undergoing a linear motion, and m is the resistance for the motion, is called mass of the body. Thank you.